Earlier, when I introduced circuit analysis, I had said that complete solution to a circuit means finding all the branch currents and all the branch voltages. Okay. Now what we have done so far is to set up nodal analysis equations, and by solving this we get all the node voltages. Okay. So how do we get the complete solution then? So let's take the nodal equations for some circuit, and use the example which we have been using so far, which is a 3-node circuit with 2 current sources and 5 resistors. Okay, and we know the nodal equations for this, which is G times the vector of voltages V equals the vector of sources I, and the vector of voltages V consists of 3 vectors V1, V2, V3, where all these are voltages of node 1, node 2 and node 3 with respect to the reference node. Okay, and this is what we solve for. When we invert the matrix and multiply the vector of current sources, which in this case is this vector I1, 0, I3. Okay. Now what did we want to solve for? We wanted to solve for every voltage and every current. But by doing this, the important part of the work is already done. Okay. Then all we have to do is to identify between which nodes each component is connected. That, with the trivial application of Kirchhoff's voltage law, will give us all the voltages. Okay. I'm going to write that down here. First of all, let's write down the voltages across every element. Across I1, all we have to do is to note that I1 is connected between node 1 and 0. So across I1, the voltage is V1. And R11 is also connected between node 1 and 0. So across R11, the voltage is V1. Similarly, across R22, the voltage is V2. Across R33, the voltage is V3. And across I3, the voltage is V3. I mean, this looks trivial, but this is just a systematic way of finding out all the branch voltages, and which can be applied to large circuits as well. Okay. And then for these components which are connected between 2 nodes, neither of which is the reference node, the voltage across it will be difference between 2 node voltages, V1 minus V2. Okay, this is by trivial application of Kirchhoff's voltage law. And here it is V2 minus V3. Okay, so we can get all the branch voltages easily once we have the vector of node voltages. Okay, and then we have to calculate all the currents. Now we use the voltages and IV relationships of the device to find the currents. Okay, so again we will do it for all of these. It is trivial for this case, but what I am telling you is a way to systematically generate the complete solution to the circuit. Okay, so if we take the current in I1 in this direction, consistent with the passive sign convention, given the sign of this V1, we will have this current to be minus I1 because this is a current source, and the current through R11 would be V1 times G11 and so on. So the current through R22 would be V2 times G22. This is the current through R22, and similarly through R33 it would be V3 times G33, and through these resistors R12 and R23 it can also be equally easily calculated as V1 minus V2 times G12 and V2 minus V3 times G23. Okay, so this is how we can get a complete solution to the circuit. So in summary, when you want to solve for every electrical variable in the circuit, you set up the equations for nodal analysis. G times V equals I, okay, where this is the vector of independent sources, this is the conductance matrix, and this is the unknown vector consisting of node voltages. Okay, and you solve this to obtain node voltages. So V will be the inverse of this matrix times I. I am showing these square brackets to emphasize that it's a matrix, and then use the node voltages to obtain all branch voltages, and finally use element IV relationships and node voltages to obtain all branch currents. So at the end of this process you will have all branch voltages and all branch currents. Okay, now of course the hard part consists of these two steps, so that's what I have emphasized. So when we say nodal analysis, that is what is meant by nodal analysis, although to get all the branch voltages and branch currents you need to do these as well. But once you have solved for this unknown vector V, these steps are rather easy. Okay.